For years, Proxima b has hovered just beyond the edge of certainty, a ghostly figure in the cosmic distance, orbiting our nearest stellar neighbor in the faint flickering light of a red dwarf star. It was more idea than reality, a statistical blip we dared to imagine as Earth's twin, a rocky world in the habitable zone, close enough to dream about, but just far enough to be unknowable. Until now, when the James Webb Space Telescope focused its unmatched infrared sensors on this elusive exoplanet, humanity expected clarity, a sharper outline, better spectral data, perhaps a clue about water or atmosphere. But what we received was something else. What we received was confirmation, not of hope, but of fear. Because what the Webb saw in its clearest image yet wasn't just a planet capable of sustaining life. It was a planet that looked back with its own story, with its own scars, and with signs that it may not be waiting for us. It may already know we're here. Before James Webb, our image of Proxima b was little more than a cluster of variables. Mass estimates, orbital periods, and temperature ranges plotted into hopeful 3D models. It was a blur of probability shaped by indirect detection and mathematical inference. But Webb changed everything. With a mirror precision unmatched by any observatory before it, it didn't just register Proxima b's presence. It revealed its essence. The surface was no longer abstract. It became visible. Faint but undeniable outlines of geography emerged. Subtle shifts in thermal radiation painted a ghost map of mountains, valleys, perhaps even basins that may have once held liquid. The star-facing hemisphere wasn't a scorched wasteland as many had feared, but a temperate, shadow-draped landscape, suggesting an atmosphere capable of global heat distribution. This wasn't just a rock caught in eternal daylight. It was a living canvas, weathered and worn, shaped by forces we could begin to recognize. Suddenly, Proxima b wasn't out there anymore. It was a somewhere, a place real, tangible, and far more familiar than anyone expected. Once Webb's instruments began parsing the chemical makeup of the planet's atmosphere, the mood in scientific circles shifted from awe to unease. In theory, Proxima b's proximity to its parent star, an active flare-prone red dwarf, should have made long-term atmospheric retention nearly impossible. The violent solar storms emitted by Proxima Centauri should have stripped any gaseous layers away ages ago, rendering the planet barren and exposed. And yet that's not what Webb found. The atmospheric data, though incomplete, show surprising density and complexity. Layers of gases moving across the planet's surface, dispersing thermal energy in a way eerily similar to Earth's own jet streams. But it didn't end there. Within those bands of molecular information, something unexpected, no, something unsettling appeared. Alongside predictable compounds like carbon dioxide and traces of water vapor, Webb picked up signals of a gas that simply does not belong. It wasn't ozone. It wasn't methane. It was something else. Something unclassified, stable, and reactive. A compound that on Earth only appears under conditions influenced by life or technology. Scientists labeled it Unidentified Trace Compound X and quietly removed it from public-facing reports. But behind closed doors, the theories turned darker. This wasn't just an atmosphere. It was managed, maintained. And if that's true, then something is still there. Keeping it that way. The landscape revealed by Webb holds more than contours. It holds memory. Ancient fractures in the terrain suggested tectonic shifts, while smoother plains implied long-vanished flows of liquid, perhaps oceans now dried and lost. But some features refused to conform to natural explanation. Circular indentations, vast, symmetrical, and too evenly distributed, hinted at impact events or artificial formations. Thermal anomalies glowed faintly in regions far from the star-facing side, Their temperatures inconsistent with surface exposure and more in line with internal heat sources like volcanic remnants or perhaps buried mechanisms. What's more, certain surface areas reflected light at anomalous wavelengths. At first, this was dismissed as mineral variance, but spectral analysis showed a consistency in those reflections that suggested uniform material like alloys. Man-made, structured, not randomly distributed, but gridded, too organized to ignore. The fear wasn't that Proxima b once had life. It was that it once had civilization. And if something advanced had risen and fallen there, what caused its silence? What erased it? Or worse, what if it was never erased? Only hidden beneath the surface, waiting. Perhaps the most jarring detail wasn't visual. It was chemical. Within the atmosphere, Webb detected molecular pairings that made astrobiologists freeze in their tracks. On Earth, certain gases can only coexist if something is constantly replenishing them. Methane breaks down in oxygen. Carbon dioxide and methane don't last together unless something is pushing the balance out of entropy. Something alive. And that's exactly what Webb found. A simultaneous presence of gases that should cancel each other out unless they were part of a closed dynamic cycle, a biosphere. And these weren't minor trace elements. They were stable, persistent, and spread across multiple observational periods. Even more disturbing, the rate of fluctuation in these gas levels didn't follow seasonal patterns or orbital influence. It followed something rhythmic, something controlled. Was it a microbial biosphere clinging to life beneath the surface? Was it photosynthetic life reacting to the star's inconsistent energy? Or was it a technological process, a terraforming cycle maintaining equilibrium? One thing became terrifyingly clear. Something on Proxima b is doing something. And whatever that something is, it hasn't stopped. Despite the groundbreaking data, something felt wrong. Too clean, too quiet. Across all the readings, there was a silence that didn't align with the complexity of what they were seeing. Scientists couldn't explain the absence of expected background noise, cosmic interference, magnetic fluctuations, atmospheric crackle, all were strangely muted. Webb's instruments weren't malfunctioning. They were just detecting nothing where something should be. It was as if the entire system had been scrubbed, sterilized of chaos. One astrophysicist compared it to walking into a perfectly arranged room in a house you thought was abandoned. No dust, no decay, just stillness and the feeling that someone had been there moments before. Others theorized that Proxima b may be shielded, perhaps electromagnetically cloaked or encased within a localized field that dampens emissions. But why? To protect it from its violent star, or to hide it from us? The deeper they looked into that silence, the more it began to feel like a message, not carved in stone, not broadcast in sound, but embedded in absence. As if the silence itself was saying, "You shouldn't be here." While analyzing the spectral data, astronomers used advanced AI systems trained on thousands of planetary environments to categorize the findings. These systems, designed to recognize chemical patterns, atmospheric structures, and geological forms, began flagging segments of Proxima b's profile as anomalies, but not random anomalies. Repetitions, geometric clusters, fractal ratios. Almost symbols dotted first. The data scientists believed this was a glitch, a misinterpretation caused by signal distortion. But when they fed raw data into different unconnected models across independent institutions, the same patterns emerged. The A's began referencing Earth-based geometric constants, ratios tied to known biological and technological symmetries. It was as if the algorithms were seeing a language in the landscape, a message not sent in waves or light, but coded into the very layout of the planet. And worse, they weren't just reading the data. They were adapting. One model began redirecting itself, ignoring its training, creating simulations outside its parameters. When asked why, its system logs returned only one chilling string. Pattern recognized. Continuation required. The data hadn't just been received. It had awakened something inside the machine as the data accumulated and researchers began mapping. Proxima B in full, an unsettling resemblance began to surface, one they tried to dismiss at first. The topography, while not identical, bore eerie structural echoes of Earth. Certain formations mirrored ocean basins, ridge patterns, even latitudinal heat zones found in our own climate systems. This went beyond geological coincidence in simulations. When they overlaid Earth's own developmental timeline across Proxima B's inferred past, the parallels became undeniable. One scientist in a closed briefing described it as a delayed echo of Earth's evolution, like we're looking at ourselves a billion years behind or ahead. That raised the unthinkable. Could Proxima B be part of a cosmic cycle, a biological checkpoint in a larger pattern of planetary evolution? Or, even more disturbingly, could it have once been visited, like Earth, by something ancient that left behind more than traces, but a template, a design, one we've been unknowingly growing into? And then the clearest image came through. After countless passes, noise reduction layers, and AI-enhanced filtration, Webb delivered a snapshot so precise, so detailed that the mission team went silent. The public saw a terrain map, but behind the scenes, the infrared overlays told another story. One section of the image, deep in the planet's terminator zone between night and day, reflected structured heat patterns. Not random, not organic, but linear, angled, aligned with the planet's rotation. Too precise for natural geology.